Hello everyone, welcome to this video. In this video they are asking us this question that for any element A and B taken from this group, and if n is any integer, we need to prove that A inverse B A whole raised to power n is equal to A inverse B raised to power n into A, right? So that means we need to prove this thing. So here, in order to prove this, where n is any integer, for any integer we need to prove it. So let's break down into two cases where n is greater than or equal to 0, case 1, and case 2 where n is less than 0. So for this first case, n is greater than or equal to 0, we can use the result of induction and prove it, principle of mathematical induction, and prove the result. So we wanted to prove this thing and we can apply the induction onto n. So when n is equal to 0, in that case we have the left hand side here, we can substitute 0 in place of n. So anything raised to power 0 means we are talking about the identity element. So it is E, right? And what about the right hand side? Right hand side would be A inverse B raised to power 0 and A. B raised to power 0 again is identity. So A inverse into identity is A inverse. A inverse into A is again identity. So you see both of them, they are equal to each other. Hence we have the result true for n is equal to 0. Next we assume that the result is true for n is equals to k. So that means wherever in this expression we can see n, we can replace it with k. So let's mark this as equation 1. Now we need to prove the result for n is equal to k plus 1. So we prove that this A inverse B A raised to power k plus 1 is equals to A inverse B raised to power k plus 1 into A. This is what we wanted to prove here in the second equation. So we consider this left hand side here, right? We can open up this power by writing its power as k into its power as 1, correct? Using the laws of exponents. Now we can apply the equation 1 here, because the value of this thing is equals to A inverse B raised to power k into A. So we can write it like this and this as such. Next we can make use of associative property to shift the brackets. So this would be A inverse B raised to power k A inverse B and A as such. A inverse now becomes identity, right? B E into B is again B, right? Next we can combine these powers, B raised to power k into B raised to power 1. It would become B raised to power k plus 1, and hence what is it? It is your right hand side here, this one. Hence you have the left hand side equals to right hand side in this case when n is equals to k plus 1. Hence the result is true for this case also. Hence by the principle of mathematical induction, we have the result true for all n where n is greater than equal to 0. This proves one part of the proof. This proves case 1. What about case 2 when n is less than 0? So let's assume and take that case. When n is less than 0, we can write n as minus of m, where m has to be surely positive quantity, correct? So for that we then have to prove that, because here we would otherwise have n and here also we would otherwise have m, and the value of n is equals to minus m. So this now becomes equal to this raised to power minus m and this also raised to power minus m. So let's take the left hand side here. For the left hand side, you can write the power minus m as the power minus 1 into m, correct? And now for onto this property, you can apply the Sock-Shoe property. So you can just reverse the order and then apply the power here. So it would be the inverse of A, the inverse of B, and the inverse of A inverse, right? This thing. Next, you can simplify this thing. What is A inverse inverse? It is just A, right? So it is just A, and m now is a positive quantity. Earlier also it was positive. So if it is a positive quantity, we can make use of case 1, which we have proved, and we can apply this result onto m. Why? Because you apply this result. Why? Because m is a positive integer, and for positive integers we already have proved our result. So applying this result onto this, we have A inverse as such, B inverse raised to power m A. You can then open up this power so that it would become B raised to power minus m. And what is it? It is your right hand side here, right? This expression. Hence you have also proved the result for n less than 0. So I hope you understood this result well. That is it for this video. Thank you for watching.